Even and odd functions, problem type 1. Even and odd describe the symmetry of a graph. An even function is symmetric about the y-axis. So if we sketch out some coordinate axes, an even function will look the same on the left and on the right. The poster child of the even function is the squaring function, y equals x squared. And in fact, that's a lot of where the name came from. A power with an even exponent always produces an even function. An odd function is a function we describe as having symmetry about the origin. The way I think about this, if you take this picture and turn it so that it's upside down, right? Rotate it halfway around so that the positive y-axis is pointing where the negative y-axis is, and the positive x-axis is pointing where the negative x-axis is, then you will see the same picture. That's what we're talking about when we say symmetry about the origin, when we say odd functions. Again, this graph is, roughly speaking, to the best of my poor writing ability, this graph is the graph of y equals x cubed. A power function with an odd exponent is always an odd function. Most graphs are in fact neither even nor odd. Consider this equation of a line. This is something in the ballpark of y equals 2 minus x. This is not an even function. The mirror symmetry around the y-axis is non-existent. This is not an odd function either. If I were to rotate this graph, I'd end up with something over here, which is very much not what we're looking for. So to identify even and odd functions, we are simply looking at the symmetry of the graph and trying to determine whether it is mirrored or rotationally symmetric. If it's mirrored symmetric, it's an even function. If it's rotationally symmetric, it's an odd function. If it is neither, then neither even nor odd.